Hey guys, so today we are doing the notes on proving lines parallel with converses. Not the shoe converses, but a mathematical converse. By the end of the period today, you guys will be able to show two lines are congruent using the converse of the corresponding angles theorem, the alternate exterior angles theorem, the alternate interior angles theorem, and the same side interior angles postulate, all the converse. And you will also be able to use these theorems and postulates to find the angles or the measures of angles. So if you think back to chapter 2 with converses and biconditionals and all that, converses are when you switch the hypothesis and the conclusion. So for example, if our conditional was if two angles add up to 180 degrees, then they are supplementary. We can flip it and say if two angles are supplementary, then they add up to 180. And that would be the converse. So taking what we did with our other notes on Monday and Tuesday, we are going to do the converse of those theorems and the postulates. So, for example, this one is the corresponding angles theorem. So, if two parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. And this down here is our is how we would list it, like in a proof, or if we were doing a if we were explaining how we got our answer. So the converse of that is that if two lines in a transversal form corresponding angles, which would be angle 2 and 6, that are congruent, then the lines are parallel. Notice how they have this little tick mark there? That means that they're parallel. Remember that it has to show in some way that they are parallel. So if those two corresponding angles are parallel in your diagram or in the directions, it tells you they're, sorry, not parallel, congruent. If those two corresponding angles are congruent or the directions tell you that they are congruent, then the lines would be parallel. So the notation for that is that corresponding angles are congruent if corresponding angles are congruent, then the lines are parallel. And you can use this notation. So write that down on your notes. I will show you in a couple slides here once we get through the theorems what else you can do. So alternate interior angles, if we have two parallel lines, then the alternate interior angles are also congruent. The converse would be if two lines in a transversal form alternate interior angles that are congruent. Again, it needs to have that congruent symbol there. It needs to have a tick mark that shows that those two angles are congruent. Then those lines are parallel. So here's the notation for that. You can write that down on your notes. Alternate interior angles are congruent, then the lines are parallel. If at any point you need to pause the video, go ahead and do that. I know I talk kind of fast and go through this fast, so work at your own pace, pause that video, and get everything written down. Okay, so same side interior angles are always supplementary when you have two parallel lines. So the converse would be that if you have two lines in a transversal that form same side interior angles that are supplementary, so angle 3 and angle 6 add up to 180, then those lines are parallel. Alternate exterior angles are congruent when you have parallel lines. So the converse would be if your two lines in a transversal form alternate exterior angles that are congruent, angle 1 and 7 are congruent, it says in the diagram, then your lines are parallel. And there's the notation that you can write down. Okay, so remember biconditionals. A biconditional was when we use the if and only if. So we can write it two ways. If our conditional was if two angles add up to 180 degrees, then the two angles are supplementary. The converse would be if two angles are supplementary, then the two angles add up to 180 degrees. Both of those are true. The conditional and the converse is true, so we are allowed to write the biconditional, which would be two angles add up to 180 degrees if and only if the two angles are supplementary. So we can actually use this style here, the P if and only if Q, or it can be, you know, Q if and only if P. So what I'm saying is we can write our notations in an easier way so that you only have to use one instead of remembering two. So if we have parallel lines, then corresponding angles are congruent, which would be the conditional, and the converse would be corresponding angles are congruent, then you have parallel lines. So the biconditional would be parallel lines if and only if corresponding angles are congruent. Or you could have corresponding angles if and only if parallel lines. So that just means if your corresponding angles are congruent, your lines are going to be parallel and vice versa. If you have parallel lines, your corresponding angles are going to be congruent. Again, you will get a sheet that has these on there. So we can write the reasons this way instead and use our double-sided arrow instead of having two different things there. Why does this keep happening? Instead of having two different theorems or two different mathematical ways to write it for each type of angle, okay? And you, again, will get a sheet that has these on there for you. Okay, so the proof of the alternate exterior angles converse. So our given is angle 1 is congruent to angle 2. So I'm going to, not with yellow, I'm going to write that in here on my diagram. And the reason behind that is that it is a given. Angle 2 is congruent to angle 3. Why would those two be congruent? They're congruent because of the vertical angle theorem, or VAT. Then, because, think back to chapter 2, because we have angle 2 in common in both of those statements, we can go ahead and rewrite our statement without angle 2. Angle 1 is congruent to angle 3, and that is because of the transitive property of congruence. Remember, we can take out that angle or that measure or that line that they have in common. So then the measure of line M is then parallel to line N because of the fact that corresponding angles are congruent, which means that the lines are parallel. And again, you can write it in this way, or you can say corresponding angles congruent means the lines are parallel. That would work too. We do not care which way you write it, just has to have some sort of explanation as to how you got that answer. Okay? So which of the following lines are parallel and why? So for the first one, we have this angle is congruent to this angle. Those two angles are corresponding angles. So that means that they're parallel because corresponding angles are congruent. So A is parallel to B. For the next one, this one here, we have a linear pair, right? But we cannot determine if A is parallel to B because we don't have any of these angles down here, okay? We would have to have a tick mark down below on that second set of lines to show that these lines are parallel, if possible. So because we don't have enough info, none of the lines are parallel, and that is because not enough info. And that is a perfectly fine answer for this one. For the next one, so yes, we have extra lines in there. No, we really don't need to use this. So if you want to on your page, you can kind of scribble it out just to help you understand this a little bit more. So I have this angle and this angle are congruent. Those are alternate exterior angles, and because they are alternate exterior angles, and they are congruent, that means that the two lines are parallel. So Q is parallel to S. For the next one, if you need to turn your paper, some of you guys have a little trouble looking at it because it's not in the correct direction. But if I extend this line here and extend this line here, my two angles are corresponding angles. And I know that corresponding angles are congruent. And if they are congruent, that means that they are parallel lines. So how we write it would be ray DA is parallel to ray BC, because technically these lines do not extend on that figure. All right, next, state the value of the question mark. That would prove line U parallel to V, and then state the theorem or postulate you use. So if you're looking at this, what kind of angles are in the first one? These two are same side interior, right? So we know that same side interior angles are supplementary, right? So I would have to do 180 minus 70 to find this missing measure, which would be 110 degrees. And that is because of the same side interior angle supplementary. That means the lines are parallel. And again, you could make it look like this too. It does not matter, just as long as you have the explanation there. For the second one, 52 and the question mark are alternate interior angles. So if they're alternate interior angles, that means that they are congruent. So the question mark would be 52. And we know that U is parallel to V because if we have alternate interior angles that are congruent, that means that the two lines are parallel. All right, so flip your page over, find the value of X that makes P parallel to Q. Lines P and Q will be parallel if the marked angles are. What type of angles are these? They are alternate interior angles, and in order for P and Q to be parallel, those two angles need to be congruent. So we can solve for X to see what it would need to be in order for my lines to be parallel. So I'd have 6x plus 34 equals 9x minus 2. And I'm going to add 2 to both sides. I have 6x plus 36 equals 9x. And then I'm going to subtract 6x from both sides. So 36 equals 3x. And then divide by 3 on both sides, so x would equal 12. You guys go ahead and try 1 through 9. Pause your video and then give it and give those questions a try. And then you can start it again and listen to the answers. So for number 1, it is possible to prove these lines parallel because 130 and 50 are same side interior angles. So they would be parallel because same side interior angles are supplementary. And 130 plus 50 equals 180. For number 2, they are congruent angles and they are corresponding. So those two lines are parallel because the corresponding angles are congruent. For number 3, there is no specific angle pair here. If these lines were parallel, you would have to have something, added into there to prove that they're parallel. Because right now, if I were to say that this would be 75 because of vertical angles here, 75 plus 115 is too much for 180. So it is not possible to prove these two parallel because the values are too much and we don't have enough information. For number 4, The x's are alternate exterior angles, and because they are both x, these lines are parallel because of that theorem. For number 5, yeah, they're vertical angles, but we don't have anything that says that is a theorem that says that vertical angles make parallel lines. So this is not possible either. For number 6, those two are congruent angles, and they also are corresponding angles. So because corresponding angles are congruent, that means that we have parallel lines. For number 7, you're just figuring out what x is. So I know that the two angles are corresponding angles, and because they're corresponding, so again, if you want to write down what types of angles they are, that is helpful to me so that I can understand your thinking. They're corresponding angles, and I know that corresponding angles are congruent, which means that they equal each other. 3x equals 45. If I divide by 3 on both sides, I get 15 as my answer. And that would make those two lines parallel. Number 8, these are also corresponding. I have one exterior, one interior, and they're both on the same side. Again, write it down so that I can give you some extra points if you did your math wrong. So, if they're corresponding angles, you can have 2x plus 10 equals 120, and then solve for x. So you'd have 2x equals 110, because I subtract that 10, and then divide by 2 on both sides, you get x equals 55. Then for number 9, you are looking at alternate interior angles, and we know that alternate interior angles are congruent. So if we have 80 equals 2x plus 20, we can go ahead and solve. 60 equals 2x, divide both sides by 2, so x would equal 30, and that would make these lines parallel. Okay, so we are going to do some practice with the theorems and postulates now. Now we have talked with other teachers and in the higher math classes, and we are kind of trying to get away from proofs per se and the specific 2-column. So you are more than welcome to do your own 2-column proof if you'd like, but you are also welcome to do some other ways to justify your givens and your proofs. So, for example, this 2-column proof, our given is that L and M are parallel, but we want to prove that angle 4 and angle 6 are congruent. So, my first statement is a given. The second statement would be that the measure of angle 3 plus the measure of angle 4 equals 180, which would be true because they form a linear pair, which are supplementary angles. Then we can write down that angle 3 and angle 6 equal 180 because they are same side interior angles, and that means that they equal 180. For step 4, we are basically taking this, we are taking our measure of angle 3 plus measure of angle 6, and we're plugging it into 180, and that is a transitive property. Then we would subtract the measure of angle 3 from both sides, and they would end up canceling out on both sides to get the measure of angle 4 equals the measure of angle 6. Then, because the measures are the same, by definition of congruence, that means that the angles are congruent to each other. So that would be how you could do a 2-column proof for this type of problem. Another way that you can do it, instead of doing the 2-column proof, is just to show some work. So what I did for this one, and again, there is no correct way to do this. You can do it your own way, just as long as you have some proof to show. So what I wrote down is I wrote linear pair, or angle 3 and angle 4 are linear pair. So that means that the measure of angle 3 plus the measure of angle 4 equals 180. Then, so you can like put an arrow here, whatever you want. Then I said angle 3 and angle 6 are same side interior. And same side interior angles equal 180. So then that would bring us down to the measure of angle 3 plus the measure of angle 6 also equals 180. And then I'm going to kind of just draw some circles and show that I can plug this in for here. And I do measure of angle 3 plus the measure of angle 4 equals the measure of angle 3 plus the measure of angle 6. And I know that these two, measure of angle 3 and measure of angle 3, are the exact same thing. And that's because of the congruent supplements theorem. So I can get rid of these. And if these two are equal to each other, they are also congruent to each other. And you can write something down like congruent supplements theorem. Again, as long as you are just drawing, or you could say this is 180, and then you could use a different color and you could say this is 180, so that means that these two are congruent. That would be fine. And you could just draw on that picture like that and say congruent supplements theorem, and that would work just fine for me. There are multiple ways to get to your answer, but it has to be legit. So you can't just draw on the picture and say, that's it, I'm done. You have to have some reasoning behind it. You could also put it in a paragraph if you'd like to. It does not matter how you do it. You can do a proof, you can draw on the picture, you can put some explanations down, all that kind of stuff. All right, so we know that for this one, the measure of angle 1 is equal to the measure of angle 7, which it also means angle 1 is congruent to angle 7 because of the definition of congruence. And we don't need to write that down because you should know that. If the measures are the same, they are also congruent. If they're congruent, they're also equal to each other. So we can also say that angle 3 is congruent to angle 1 and angle 5 is congruent to angle 7 because of the vertical angle theorem. So angle 1 is congruent to angle 3 and angle 5 is congruent to angle 7. Now, because angle 1 and angle 7 are congruent already, that was our given, or part of our given, we can use the transitive property to help us say that angle 3 is congruent to angle 5. And that is one way that you can do it. That is one approach. Another approach, I'm going to erase this and do it in a different color here. Another approach would be that, okay, angle 1 and angle 7 are congruent. And if angle 1 and angle 7 are congruent, that means that they are alternate exterior angles, which means that A and B are parallel. And if A and B are parallel, we know that the alternate exterior angles are also congruent. So you could say angle 3 is congruent to angle 5 because of the theorem. Parallel lines means alternate interior angles are congruent. So this side would be one way, this side would be another way to answer that question. Again, you obviously need to draw or write something. You can't just put the tick marks in and expect us to understand your thinking. You need to have some kind of writing there. We are allowing you not to do proofs, which be thankful for that because proofs can really stink sometimes. We're trying to get away from that. So make sure that you are explaining your thinking here. Obviously, it doesn't have to be in super depth, but explain how you got there. So our given is that L and M are parallel lines, and we need to prove that angle 1 and angle 2 are supplementary. So again, there are a couple different ways that you can do this. So first of all, I know that angle 1 and angle 3 are congruent because of vertical angle theorem. So angle 1 is congruent to angle 3, and we can just say vertical angle theorem. So that would be my first step. Then I know that angle 3 and angle 2 are same side interior, which means that they need to equal 180. So if we have angle 3 plus angle 2 equals 180, and that is because of the same side interior angles are congruent because the lines are not congruent, are supplementary because of the parallel lines. Then we know that angle 1 plus angle 2 equals 180 because of the congruent supplement theorem, which means that if two angles are supplementary and another two angles are supplementary that have the same angle in common, which would be in this case dang it. Which would, sorry, not in that case, which would be, oh my gosh, I lost my train of thought here. Hold on, guys, sorry. Well, yeah, I guess that would be the same thing. Congruent supplement theorem, I just want to erase this little piece here. There we go. Okay. So the congruent supplement theorem basically means that I can, so angle 3 and angle 1 are the same thing. So I can swap angle 1 for angle 3 and go ahead and say that they are equal to 180, angle 1 plus angle 2, because angle 1 and angle 3 are the same exact measure. Okay, then I can do it in a different way. In this way, I'm kind of doing like a paragraph style, but I can say angle 1 and angle 2 are supplementary because if angle 3 and angle 2 are supplementary and angle 1 and angle 3, or angle 1 is congruent to angle 3 because of the vertical angle theorem, then we can switch or do the transitive property, angle 3 for angle 1. Or vice versa, I'm sorry. Angle 1 for angle 3. So let me know if you guys have any questions. There is a half sheet of homework to do. Please make sure that you upload that to Canvas. You do not need to upload the notes anymore. It's just too much work for you guys, and a lot of you did not, or had the notes done, but we're just too lazy to put it on Canvas. So I'm just having you upload the homework from now on. Let me know if you have any questions, and see you guys later.